Calculus. Just hearing that word makes a lot of students nervous. Some people think it's only for the geniuses. Others think it's impossible. Then there's that one student who always opens the chapter and immediately wants to close the book. Hmm, what even is this chapter? Oh man, this is so hard. I might even fail my test tomorrow. Well, if you ever felt like this, do not worry. You are not alone. Most students see calculus and think it's a mountain of scary formulas. But today, I'm going to show you that differentiation is based on one very simple idea. Don't worry, I'll be teaching you in simpler terms. In fact, by the end of this video, you will realize that differentiation is simply the mathematics of change. So, let's dive in. Before we talk about differentiation, let's talk about something you already know: velocity. Suppose you are driving from one place to another. You travel a certain distance in certain amount of time. To calculate a speed over the entire journey, we will have to use the formula for average velocity. This formula says that velocity average, or the average of velocity, is equals to delta x by delta t. Here, delta t means the change in time and delta x means the change in position. The symbol delta or the triangular symbol simply means change in or the difference in. So, average velocity tells us how fast an object moved over an interval of time. Well, now imagine these 2 points, A and B. We can find the average velocity between these points. But what if I ask a different question? What is the velocity exactly at this moment? Not over an entire time interval, not between 2 points, but at this one exact instant. Well, the thing is, average velocity can't answer that. So, the brilliant mathematician came up with a crazy idea. They started bringing 2 points closer and closer together, closer and closer, until the time interval became almost zero. When the change in time becomes infinitely small or very small, average velocity becomes instantaneous velocity. And then we write it as v, or velocity, equals to dv by dt. Here, d means extremely tiny change. So instead of asking how much position changed over a period of time, we can ask how fast is position changing right now at this exact moment. And that exactly what differentiation actually is. Differentiation is the process of finding the rate at which one quantity changes with respect to another. It measures how a tiny change in one quantity might affect other quantity. Geometrically, differentiation tells us the slope of the curve at a particular point. If the curve is rising, the derivative is positive. If the curve is falling, the derivative is negative. And if the curve line becomes flat, the derivative is zero. Well, why should we care? You might be wondering, why do we even need this? Or why do we have to learn this? Well, that's because the world is constantly changing. The speed of a car changes, the temperature changes, the population of city changes, the amount of money in your bank account also changes, the growth of plant also changes. And differentiation gives us a mathematical tool to study all these changes. So, if I had to explain differentiation in one simple sentence, I would say this. Differentiation is the mathematics of instantaneous change. It tells us how fast something is changing at particular moment. Well, whenever you see dy by dx, you should be able to read it as the rate of change of y with respect to x. Or whenever you see dx by dt, you can tell how quickly position changes with the time, which is simply instantaneous velocity. So now we'll have to learn how to differentiate different functions. There are mainly five types of functions which we will differentiate. The first function is the algebraic function or the algebraic function. The second function is the trigonometric function. The third function is the exponential function. The following fourth function is the logarithmic function. Fifth function is the inverse function.
So now let's understand the different functions for which differentiation can be done. The first function we would be taking is the algebraic function. So rather than doing the differentiation from the start, let us understand what an algebraic function actually is. So this is any value x raised to the power n, where n is a number or an integer, you can say integer. Okay, and x is a variable, so the value of x can change, but the value of n will be fixed. For this, there's a very simple way to differentiate this, and you have to understand and learn the general form for this, which is differentiation of x to the power n, which is given that y is equal to x to the power n. So differentiation of y with respect to x is equal to differentiation of x to the power n with respect to x, which is the same as n multiplied with, here n is the power, n multiplied by the x raised to the power n minus 1, where n is exponent value. Okay, so now let's understand it better using an example for y is equal to x raised to the power 6. So dy by dx is equal to dx to the power 6 upon dx. So here n is 6. So the differentiation for this on comparing to the standard form would be n, which is 6 multiplied by x raised to n to the power 1, which is 6 minus 1, n minus 1, sorry, which would be written as 6 multiplied by x raised to the power 5. Here, the value of n can be positive, negative, or a fraction. So let us take an example for which the value of n is negative. Let us take y is equal to x raised to power minus 2. So dy by dx is equal to d x की power minus 2 upon dx. So we can use the general form again. Here n is minus 2. So this will be minus 2, which is n multiplied by x raised to the power minus 2 minus 1, which is minus 2 x power minus 3, which can also be written as minus 2 upon x to the power 3. Now we can also try it for an fraction, which would be y is equal to x raised to 1 by 2. So dy by dx is equal to dx to the power 1 by 2 upon dx. Here n is 1 by 2, so we can solve it as 1 by 2, which is n, multiplied by x to the power 1 by 2 minus 1. This can be simplified to 1 by 2 into x to the power minus 1 by 2, which can also be written as 1 upon 2 root x. So I would like to give you a homework to solve, which is differentiation of y, where y is equals to x raised to the power 4, where y actually is equals to x to the power minus 3, and where y is equals to x to the power 3 by 4. So solve these three questions and drop the answer in the comment box, and I'll reply to it whether it is correct or incorrect. So now let's move on to the next function, which is the trigonometric function. So for the trigonometric function, you have to memorize 6 values for the differentiation of different function. The first one is differentiation of sine x with respect to x, which is simply just cos x. The second function is differentiation of cos x. Differentiation of cos x. with respect to x. This is negative sine x. Here, note that negative is very important because people tend to forget the negative sign and lose marks. So please remember the negative sign. After that, after this, there's the differentiation of tan x with respect to x. This would simply be sec square x. Then there's the differentiation of sec x with respect to x again, which would be sec x multiplied by tan x. After this, it would be the differentiation of cot x with respect to dx, obviously. This would be negative, note negative cosec square x. People often tend to forget the negative sign here also, so please remember it. After this, there's a differentiation of, you guessed it, cosec x with respect to x, obviously. So this would just be negative cosec x multiplied by cot x. So you have to basically memorize these six formulas because these will help to solve the future problems in which there are the different rules for differentiation. So now let's move on to the next function, which is the exponential function. In the exponential function, uh, it is e raised to the power x, where the base, which is e, is fixed, and the power, which is, we can say the exponent, is variable. You might think it is very similar to the algebraic function, which was uh, x raised to the power n. But here, n was fixed. The variable here is x, which is variable, so it changes accordingly. It can the value of x can change, but the value of n can never change. Here, it's the opposite. The value of e, which is the base, can never change, but the value of x will change. So for the derivative or the differentiation of this, it is actually very simple. We just have to rewrite it. It's just the differentiation of e to the power x is just ex. This is the general form. You should remember this. It is very easy and very useful in some type of questions, though not useful in every question. Now, after this, let's move on to the logarithm function. This is also a topic where children often get stumped or they do not understand what logarithm functions actually is. So now let me first make you understand what logarithm function actually means. So let us say that you would represent 10 to the power 2, which is 10 square, as 100 because 10 square is simply 10 into 10, which is 100. So to write this in log form, we would have to take actually take the power here and the answer, which is 100, here. So it would simply be log of base 10. This is called base. Log base 10 bracket 100 is equals to 2. This is the basic of logarithm. Now, there is also the natural log, or you can, which is called as ln x or log of ex. So y is equals to log base e bracket x, which we simply denote as ln x, as seen in many cases. You can also try to find the convert uh, to cube, which is 8, to logarithm. That would simply be, we would take 3 here, take 8 here, and the 2 will become the base. So it would be log 2, 8, which is simply 3. It's kind of very easy actually once you start to understand the patterns, though there's a more deeper concept in this, which is very difficult to explain. So I would rather take it in a different video than extend in this video. So now let's understand what is the derivative of the logarithm function. For logarithm derivative, we'll be only studying the the derivative of natural log or ln x. So derivative of ln x with respect to x can be written as simply 1 upon x. It is very simple and it is very useful in the questions in which there's the derivative log is required and all. Also, the inverse. Now we'll be moving on to inverse function. This inverse function is kind of similar to the trigonometric functions, but here we would also have to learn the values of basic six inverse functions. The first inverse function is differentiation of sine inverse x with respect to x. But before you can understand what this actually is, let us understand the meaning of an inverse function. An inverse function, for example, we can say sine 30 is equals to 1 by 2. Now we are given the angle here. Let us take it at as theta. If we are given that sine theta is 1 by 2, to find the value of theta, we can write theta as sine inverse, which is represented as sine raised to the power minus 1 multiplied by 1 by 2 or bracket 1 by 2. So the value of theta here would be 30 degrees because we can match it to this equation. So now let's learn the or understand the inverse function differentiation of inverse functions. First, we would take the inverse function of sine inverse x. It is simply 1 upon root 1 minus x square. Feel free to rationalize it, though it doesn't matter much in questions. It would not be so complex that you have to rationalize it every time, but you can rationalize it. So if you want, you can rationalize it, or if you do not want to rationalize it, you don't. So now let's move on to the next function and to the next inverse, which would be differentiation of cos inverse x. Cos inverse x. This would be negative 1 upon root 1 minus x square. Simple enough. Then we would be looking at differentiation of tan inverse x, which is simply 1 plus x square plus 1, or 1 plus, this is or not upon 1 plus 1 plus 1 upon 1 plus x square. Now, differentiation of cot inverse x. Don't forget to write the ones here, like I forgot. People also tend to forget that, and if the checker finds the mistake, he or she might cut marks. So please keep that in mind. Now, the derivative of cot inverse x would be negative 1 upon x square plus 1, or negative 1 upon 1 plus x square. Now we'll see the derivative of sec inverse x with respect to x, obviously, which is 1 upon x root x square minus 1. And similarly, derivative of cosec inverse x with respect to x. This is inverse x, which is 1 minus 1 upon x root x square minus 1. So these are the inverse functions which you have to
Well guys,
remember.
thanks for watching the video. If you have any doubts, drop them in the comment section. Like, share and subscribe. And the second part of this will be uploaded soon as I am busy with my exams right now. So keep watching, keep learning.